All right, so the last unit we worked on compared had one variable statistics. Now what we're going to be doing is comparing two different data sets. And what we're going to be trying to determine is if there's correlation. Correlation means, does one thing affect the other? For example, does my shoe size affect my height? Or does my homework grade affect my test grade? Or things like that. So we're going to be studying two different data points and seeing, does one affect the other, or does one have a correlation on the other? So bivariate statistics just means that we're comparing two different data sets. So now scatter plots are plotting different sets of data. So let's just come up with different types of scatter plots. And a strong positive correlation would be a scatter plot that looks like this. And these are all different values that are being plotted. That's a scatter plot, because they're kind of scattered all over the place. So we would be giving a bunch of ordered pairs, we plot them individually, and this is the type of graph that we get. So this would be a strong positive correlation. A moderate positive correlation, before we move on, just take a look. It's strong positive because the slope of the line that passes through there, the line of best fit, would be a positive slope. So there's the line of best fit, so therefore it's a strong positive, because if you take a look at the plots, they don't really differ far from this line. So that's a strong positive linear correlation. A moderate positive would look something like this. Yeah, there's a couple of outside, but the general shape of the graph is still increasing as we go along. So there's a moderate positive. Yeah, there's a couple of outliers, but for the most part, they all kind of line up with the line of best fit. So this would be a moderate positive linear correlation. No linear correlation would be like this. There is no correlation here. These things are just all over the place, and my conclusion here would be that this value does not affect this value. The conclusion here, this value affects this value moderately, and this conclusion would be this value affects this value very strongly. So as this increases, this will also increase. As this increases, this will also increase. As this increases, I have no idea what's going to happen here. So now we could also have negative correlations, and that's just the converse of what's going on in the previous. So there would be a strong negative linear correlation, a moderate negative would be like that, and no correlation would be something like that. Now, that doesn't mean there's no correlation. There's no linear correlation. That does look like the graph of something, and we'll investigate that in the future, but there's no linear correlation here. So this is just, the point here was just to show you different types of scatter plots and the types of correlation that we could get. Correlations can be either strong or weak or moderate in either a positive direction or a negative direction. So the conclusions on these sets of graphs is that as this increases, I know this will decrease a lot. As this increases, this will decrease moderately, and we can't really draw much of a linear conclusion in this case. So here's a table of values, and what we're going to do, we're going to find out how to calculate a correlation coefficient, and what does this number represent. So what we're going to do is we're going to construct a scatter plot, we're going to draw a line of best fit, and we're going to determine the correlation coefficient. Before we determine this correlation coefficient, let's just go back to these and define some values for a correlation coefficient. A correlation coefficient is represented by the variable R. R equals 1 is a very strong, that's the strongest possible correlation coefficient. Correlation coefficients can range from -1 to +1. It will never be outside of that window. It's from -1 to +1. R equals 0 is a no correlation. So if R is positive, then there's a positive. A moderate positive would be something like R equals 0.7 or 0.6. You know, it's kind of an ambiguous line that is difficult to define exactly, but the closer you get to 1, the stronger the positive correlation. The closer you get to 0, the weaker the positive correlation. So conversely, r equals -1 is a very strong linear correlation, where r equals 0 is no linear correlation, where a moderate negative correlation would be r equals -0.7 of some sort. Okay? So now that we have defined some values of r, we're going to find out how to calculate it. So what we're going to do, we're going to put this information in a calculator. We're going to have to be careful what we're defining as the independent variable and the dependent variable. Your independent variable is your x value if you go back to your L1 and L2. So independent goes in L1. So how do you know which one is the independent and which is the dependent variable? We're trying to determine, does your homework grade affect your test grade? If the one that is trying to be affected by is the dependent variable, which is on the y-axis. Independent means this is the one affecting the other. And time is typically your independent. In this case, we don't have time. So homework will be the x value and test will be the y value. So we're going to put these values into our calculator. So stat, and we're going to edit our list. I already have these numbers populated, so put them into your L1 and your L2. Your L1 will be homework, and your L2 will be tests. So put them into your calculator, and now what we're going to do, we're going to construct a scatter plot. The way we'll do that, second y equals, which is stat plot. So push second y equals, and you'll see written in blue above y equals stat plot, and we want to turn plot 1 on. Right now it's off, so scroll over, turn it on. Now this is asking you what type of graph do you want. The first one highlighted is a scatter plot. X list, L1, Y list, L2, and mark means how do you want these things to look on your plot. I'm going to choose little boxes. Okay? Lastly, we're going to push zoom, and we're going to go down to zoom stat. Trig, integer, stat. There we go. So zoom 9. And then here's our scatter plot. So you can see that there is a pretty strong linear correlation between homework grades and subsequent test exams grades. So what we want to do now is calculate the correlation coefficient. The way we'll do that is stat button again. Now what we want to do, we want to calculate. What are we looking to calculate? We're looking to calculate the linear regression. So 4. Okay, so push enter. And now we have our values for R. Notice, there's R. So now, if you don't have an R in your calculator, that means your diagnostics have been turned off. Your diagnostics will be turned off if your calculator's memory is clear. So the way you turn it back on, you just go down to catalog, which is second 0. Scroll down to diagnostics on. So that means you have to scroll all the way down to D. And keep pushing enter until you see done. So it's a lot easier on the calculator. On the small board, it's just a little slow. But just keep scrolling down until you get to diagnostics on. And keep pushing enter until you get to done. And then recalculate your linear regression. We're getting there. We're getting there. Diagnostics off, diagnostics on. So push enter again, done. So now we can calculate the linear regression again, and that's in the event that R is not visible. So again, we'll go to stat. We have our list populated. We're going to calculate the line regression. Enter. Enter one more time. So here's our value of R. Our value of R is 0.9589. So there we go. We constructed a scatter plot. We did not construct a line of best fit. We can draw a line of best fit, or we can plot an exact line of best fit. So the correlation coefficient I got right from the calculator, That's exactly what I'm going to do with my line of best fit. It's going to be y equals, and we'll go back to our calculator and copy it down. Notice the format of line regression. Line regression is y equals ax plus b. Here's a, here's b. We're going to plot it on there. So a is 0.5729. X plus b. And b is given as 33.888. We'll say 8876. So this is the value I'm going to put into my calculator in my y equals. So put it into your y equals. One window. Y equals. Let's clear that out. And my y equals should read 0.5729. 0.5729x plus 33.8876. And now we'll just graph again. And there's our line of best fit. Yeah, we could have probably drawn that by hand, but it wouldn't be as exact as this. So if they ask you to draw a line of best fit, they're just asking you to kind of estimate. If they're asking you to calculate a linear regression, this is the way you do it. So what we did there, again, we pushed the stat button, and we simply said calculate the line regression, so option 4. And then push enter again, and it'll give you all your values. After it gives you all your values, it gives you the form of the equation y equals ax plus b, where a is this and b is this, and r is your correlation coefficient. So that's how you find the correlation coefficient. Again, the difference between the values of r will tell you whether it's strong or weak, or whether it's positive or negative.